Okay, for lesson 3 here today, it's a pretty short lesson. Again, we're now looking at equations in the form x to the exponent n equals a by factoring and graphing. So kind of the same as yesterday, but just a different form of an equation. Okay, so if you were to look at this example here, we want to solve the polynomial function x cubed, so that is that x to the exponent n equals a, by using the following three. We're actually only going to look at two. The textbook goes over three, but the second one is just like kind of the same as the first, where it's like a guess and check type of way. So I don't really need to show you two of those. Like I'll show you one using our graphing calculator. The second one is almost the same, so I'm not going to go over that. And then the third one, though, is using algebra and actually factoring, so that one is important as well. And we're going to round our answer to 2 decimal places. Okay, so our first one is to use a graphing calculator to graph the function, and then we're going to use the trace feature to find out what the value of x will produce. So this is the example that I have on from Desmos. I'm actually going to bring you to Desmos though, so I can show you exactly what I'm expecting from this. Okay, so I've just graphed f at x equals x cubed. So that is your equation on the left, and what I want to find is where it equals 13. Okay, so if you are to look at your graph here, all you're going to do is your y is going to equal 13. So what you're going to do is go over and you're just going to essentially hover over. That's kind of what the trace feature is. You're going to hover over around this y value, around this y value being about 13. So you can see, I can't get exactly on, I'm also using my like whiteboard thing. I can't get exactly on 13, but our value anywhere really close to 13 is about 2.35. Okay, 2.356 a little bit as we go a little bit higher, but it's essentially about 2.35. If we go a little bit lower, it's 2.348, which would round to 2.35. Okay, so when you're doing that, you're like essentially estimating, and you're not really able to determine an exact value. So by using a graph, it's definitely an approximation. Okay, it doesn't really give you the exact value. It can if it's a nice number, but for this example, it's not a very nice number, right? Like it's definitely guessing at the value of 13 here. It's definitely guessing. It's essentially 1, 2, and then you're guessing how far along that x-axis it is. So the actual value is between 2.35 and 2.36, but closer to 2.35. So therefore, this is our guess. Okay, that is our guess from using a graph. Again, not a very difficult thing to do. Just go into Desmos and graph it, and then you are estimating using that trace feature. Okay. However, we are able to actually very accurately find out what our answer to this polynomial equation is for x by factoring. Okay, so to be able to factor, all you're going to do is solve by taking the cube root of both sides. Because you have a cube here to get rid of, remember that just like squaring something, you take the square root of it. Okay, same thing. If you cube something, you're going to take the cube root of it to solve it, to do the opposite thing to it. So remember, the cube root or the square root is like you would think looks like this, right? That is essentially what you think, but that's for squaring. For cubing, remember, it's like this. So that is equal to x to the 1/3. Remember our rational exponents. Okay, so when you do that, you're actually going to keep what you have and put it to the power of 1/3 equals 13 to the 1/3. That cancels this out. Why? 3 times a third is 3 over 3, which is 1. So that leaves us with x to the exponent 1, which is what we want. That's why we did the opposite, so we could solve for x there. Okay, so again, 3 over 3, 13 over 1/3, so x is equal to 13 to the third. Put that in your calculator. Putting that in your calculator, you can either do the cube root of 13, or you can put 13 to the exponent 1/3. Make sure you keep that in brackets when you put it in your calculator, so it makes sure gives you the correct answer, and make sure that you get 2.35 for that. Okay, so that gives us a way more accurate answer than just guessing on our graph. Okay, so you're going to actually have to use this quite a bit in your homework. Okay, just some examples here. These are actually from your textbook, so I don't have you complete them. So how do you get rid of something? The cube root of 9, well, that's like 9 to the half, which is 3. What about the cube root of 27? So 27 to the third, or it is 3. What times itself 3 times equals 27? What times itself 4 times equals 625? So it's like 625 to the quarter. That is 5. And then what times itself 5 times is equal to 243, and that is 3. Okay, sorry, I forgot to write that middle step there. I forgot something, 243 to the 5th. Okay, so that is what you're essentially thinking of when you're doing these. So you don't always only have the square root and the cube root. You can take the 4th root. I can ask you to take the 5th root of something, and just remember that turns into those rational exponents. Okay. What about something like this? So solve the following polynomial equation. Round your answer to 2 decimal places. So remember, we're solving for x is what we want, so we need to isolate x. So our first step here would just be to bring this 1 over. We don't like that. So 5x to the negative 3 is equal to 8, and then subtract 1 there. 5x to the negative 3 is equal to 7. Okay. Then we still don't like this 5 here, so get rid of that 5. We'll divide both sides by 5. So 8 x to the negative 3, and then you are going to do, or just leave it as 7 over 5. Okay, then your best way to get rid of this, remember we want this to equal 1 to get rid of this. Okay, so you're going to take x to the negative 3, and what do we want to multiply it by? Negative 3 times what is going to equal 1. Okay, well, you're going to want a positive 1 here, so let's times it by negative 1, and then all over 3. So negative 3 times negative 1 is positive 3. 3 divided by 3 is 1. So we're going to raise it to the negative 1/3 is equal to 7 all over 5 to the negative 1/3. What you do to one side, you have to do to the other side. Okay, that cancels that out. That's why we did this. Negative 3 times negative 1/3 is just 1. Okay, and then remember, solving this, to get a positive exponent, you have to flip your fraction, which would then be the cube root of 5 all over the cube root of 7. Okay, and then to solve it, it says to solve to 2 decimal places. So you're going to put that in your calculator. So the cube root of 5, which is 1.70997597 all over the cube root of 7, which is 1.912931183, and then you're just going to divide that. So your answer is approximately 0.89, and that is rounded to 2 decimal places. Okay, so therefore 5x negative 3 plus 1, 8. gives a value of x approximately 0.89 when you solve it. Okay, so that one's a little bit trickier just because of this negative exponent, but don't let that freak you out. Remember, a negative times a negative just becomes a positive. Okay, so just remember, here's some key concepts, equations from of the form x to the n equals a, where n is a whole number, can be solved by taking the nth root of both sides. So if you have this example here, if n is odd, then the nth root of a is equal to a to the 1 over n. If n is even, then it's plus or minus that. Don't worry too much about that. But the example there, x cubed equals 8, then x equals squared. But if it's to the positive 2, because it's even, if n is even, then it's going to be plus or negative 2. Don't worry too much about that. Just remember to take the nth root of the equations when you're doing your homework. Okay, you can solve them algebraically by factoring or by graphing. Most of your homework is going to be factoring, but you may see some graphing. Okay, good luck. Let me know if you have any questions.